This video will help you do the A questions on the homework that's called homework on work. Now, you can just try these questions and even get them wrong and still get full credit for completion. But this video will show you how to do number 27, and if you can do that one, you can do the rest of them. So it's given that you have a block with a mass of 8 kilograms, and the only force on it is 25 newtons. So right off the bat, you should figure something out, write down something before they even ask you any questions. This is a good way to do any word problems, is if you realize that the givens are telling you something easy, go ahead and figure it out and write it down. That will train your brain better to realize how one thing leads to another and also to work independently. So let's see what we have. We have mass and force. So we think, oh, if I have mass and force, F equals ma means I can find the acceleration, and so I can find the acceleration is 3.125. And since these are only notes and work, I'm not writing any units until I get to a final answer. Okay, so I wrote that down. I don't even know if I need it yet, but that follows immediately from knowing this is the only force and this is the mass it's acting on. All right, they also give me a distance and they ask me for work, and work equals force times distance. That's the definition. We'll put 3 lines. That's the definition of work. You take the force being applied and how far it's being applied, and that tells you work, which is a measure of like how many calories you would burn, that sort of thing. So they asked for the work done by this force. 25 times 4, of course, is 100, and since this is an answer, I'm going to write the unit, so 100 joules. And in 27, 28, 29, and 30, the work is always 100 joules, and it's asking you to spot a pattern from that. Right, and then the final part of the problem asks for final velocity. And I'm talking fast in these videos, and a lot is written down already because I know you can pause it, unlike live class. All right, so they asked for that. So let's see what I have. This is a d, and d is not in our equations of motion, but that just means we have a different letter in the equations of motion for the same thing. So this means in our equations of motion, they're telling us delta x is 4. What else do I have? It said it started from rest. Vi is given as 0, so I have that. Delta x equals 4 from there. And now I'm going to use that acceleration I found earlier. You can't do the problem unless you find that acceleration. All right, and now I have 4 letters. So it's just like in the first semester, I need one of my 4 equations of motion. Look at these 4 letters. Okay, I'm going to use the 4th equation of motion. Vf squared equals Vi squared plus 2a delta x. We're going to skip over plugging and solving with algebra and go right to the answer because we've done so much of that before. You'll get Vf equals 5 meters per second. Not only do you get that answer for number 27, but you also get that answer for number 28 and 29. And then in each of those, what's constant, what's the same, is that the work done is always 100 joules and it always starts from rest. So in number 30, they say, well, what if I don't tell you any of the other specifics? I just tell you 100 joules of work is done on something starts from rest. What do you think the final speed would be? And you should guess that it's 5 meters per second.